All right, what's up? Let's go through the homework, make sure all the things that you're asking about are clearly understood step by step. So let's see what we got first. X equals 8, that means every point has an x value of 8. So 8, 0 is a point, 8, 3 is a point, 8, negative 3 is a point. So that creates a vertical line going through all those x values of 8. Now y doesn't matter because there's no y in the equation, but 8 is always the x value. So let me start the next one. We got a negative 8 here. And we're going up 7, right 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Same thing again. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So that looks like that's the point 8, 6. Okay? The point where they intersect is at 8, 6. So the next one we have y equals 8. That means all the y values are 8. And so we're going to go and draw a horizontal line where y is 8. And now the other one's going to take a little bit of work to get y by itself. Let's subtract 7x. Negative y equals negative 7x minus 1. We're going to divide everything we got by negative 1 to see that that's 7x plus 1. So starting at 1 as the y-intercept, going up 7 and over 1, and that shows us that the solution for this is 1, 7. 1, 8 rather. That should be 1, 8, not 1, 7. 1, 8. My bad. So being able to solve when it's a standard form problem requires you to be able to solve for y correctly and carefully to see exactly what you're graphing. Okay, so substitution we talked a little bit about yesterday. We're going to substitute this value in for y. 2x minus 13 equals negative 5x plus 8. That's our first process, is setting it up where these are equal to each other. Let's add 5x over to make 7x. Let's drop negative 13. Let's drop 8. And then let's go ahead and move 13 away from x to be with its like term to give you 21. 7x equals 21. And then let's finish the problem out dividing by 7 to get x equals 3. So we do have to go back into the problem, and it doesn't matter which one you use, but we've got to plug it into one of them, 2x minus 13. And we're plugging the 3 in that we just got for x. So we've got 2 times 3 is 6, minus 13. It looks like that the y value is negative 7. So that is your solution, 3, negative 7. If you were to plug in 3 into the other one, it would have also given you negative 7, and that's because they've intersected at that particular value. So the second one is a little different because they're not both y equals. One of them is y equals, but the other one is in standard form. So we're going to take this negative 6x minus 4y equals 14, but we're going to plug in this 4x minus 20 that tells us what y is from the first one. So notice that I do not put y in the problem. Y was where 4x minus 20 is now, and it's substitution. I took the y out, and I put 4x minus 20 in. So let's solve and see what we get. This negative 6 still needs to stay in front, but this is now negative 16x. Negative times a negative, this is now positive 80 equals 14. So when I'm combining like terms here, this is going to give me negative 22x plus 80 equals 14. And I'm going to keep going until I get x completely by itself. Let's subtract 80. 14 minus 80, I think that is negative 66. And when I divide by negative 22, I find out that x is positive 3. So now I've got to go back in and figure out what was y when x is 3. So I think what I'll do is I will plug it into the top one because it says that y equals 4x minus 20. But now I can use the fact that we calculated x to be the value of 3. So we're going to plug it in up here. So that gives us 4 times 3, 12, minus 20 though, it looks like y would have to equal negative 8. So our final answer for this one is 3, negative 8. That is the point where those two would meet or intersect. So if you need to pause the video to get all that down. Definitely want that to be something that you're able to perform on the quiz tomorrow when we're solving with substitution. So elimination is slightly different. We're going to start by trying to see if we have opposites of the same coefficient of x or same coefficient of y. And so number 11 is kind of an easier problem. They're ready to go because if I was to add these two equations together, you would get 0 x's. You actually get 0 y's as well. And then that equals negative 8. Well, because all the x's eliminated, this means that the answer is no solution. These are two parallel lines, and parallel lines never cross, so they never have a point of intersection, so there's no solution at all. So that was a level 1, but it did have a little swing to it with the whole no solution as an answer. So let's see if this one comes out to be any different. I don't really have anything that would cancel immediately, but I like the fact that I have a plus and a minus for the y values. So I bet 3 could become 6 if I multiplied by the right number. So I'm going to multiply that by 2 so that it gives me positive 6 there. So 2 times 18 is 36x. 2 times 3y is 6y. And 2 times negative 18, I think that is negative 50. No, negative 36. Cool. Alright, so now I'm not lazy when I do this stuff for you guys because I really want to make sure I get the problem correct. So I take a moment just to rewrite the other problem right below it instead of trying to add through that middle equation of 18x and 3y and all that. I went ahead and just rewrote the top one again. So remember we're adding these together. This gives me 0. 36 plus 9 is 45. And if you add these together, you get negative 45, which I like because it's giving me negative 1 as an integer, which means it's going to be a little easier to input. So let's plug in negative 1 and see what we get. It doesn't matter which equation you do. So I'll just do the first one, 9x minus 6y equals negative 9. And so I'm plugging in negative 1 here. So I'm plugging in negative 1 to the top equation where x is. 9 times negative 1 is negative 9. Subtract 6y and that equals negative 9. So I'm going to go ahead and add the 9 from the left side to the right side, but you actually get a 0. And the final thing I'm going to do is divide that by negative 6 to show that, well, 0 divided by negative 6 is 0. So it looks like my final answer is negative 1, 0. Okay. Again, pause the video, rewind it if there was something that you missed, and you can definitely get your questions answered. Thank you for watching the video, and I hope it helps you improve your skills on solving systems. These are things in IXL that I really want us to work on because it really helps us understand each one individually, and you can practice each one that you really struggle with. So for example, the first one is understanding what makes something a solution. When you plug those points in, it's either true or false. So if that's something you're still developing, try U1. U2 and U3 both have to do with graphing. One has to do with more just graphing them immediately and seeing where they cross. And U3 is a little more difficult. You have to kind of think about context and then graph it, see where they cross. U8 and U9 both have to do with substitution. One is just immediately working with the problem to try to substitute the values to see if you can get the point of intersection. The second one is more based on word problem setup. So check that out if you want to practice some word problems. U10 and U11 both have to do with elimination. The first one has to do with just problems given to you like we just did. And then the second one's really showing you how it works based on word problem setup. So give that a shot if you're concerned about word problems. The last thing is yesterday we introduced the idea of graphing an inequality where you shade. You either have a dashed line or a solid line. And you're either shading less than if you see a less than symbol, or you're shading greater than if you see or a greater than or equal. Okay? Solid line with an or equal, dashed line when it's not or equal. All right, thank you so much, and good luck in your practice.